Welcome back. Yes, there are more practice problems. They keep on coming. This, at least, is something we've seen before. They're asking what quantity of electricity, in other words, charge, in other words, how many electrons would it take to make, and they even use 200 grams again, but for new metals. So we're considering 200 grams of aluminum, 200 grams of magnesium, 200 grams of potassium, and 200 grams of iron. So we want number of moles first, meaning we need molar masses. Aluminum is 2698. I'm going to do all the math at once. Magnesium is 24.31. Potassium is 39.10. And iron is 5585. I think I'm going to double check that. I haven't done anything with iron in a bit. Yep, 5585. So now we do a lot of calculator punching. 200 divided by 2698. 7.41 moles. Moles of aluminum. For magnesium, 200 divided by 24.31, 8.23. 200 divided by 39.10 is 5.12. Potassium. And 200 divided by 5585 is 3.58. Moles of iron. Now, the amount of electricity is based on moles of electrons, so one more step. If we're making aluminum, we would have to add 3 electrons to each ion to make an aluminum atom. So this is 3 electrons per 1 aluminum. 7.41 times 3 is going to be 22.23 moles of electrons. For magnesium, the ions are 2s, so we're going to need 2 electrons for every magnesium we want to make. 823 times 2 would be 1646. Electrons. Potassium is easy because it's a plus 1. 1 electron per potassium we want to make means they're the same number, 1-to-1 ratio. And for iron, we're talking about iron 2, so multiply this by 2 and we get 7.16. Sorry, times 2 electrons per iron gives us 7.16 moles of electrons. Which one takes the most? The biggest number is 2223, so aluminum is the most expensive to plate. And indeed, aluminum metal is kind of expensive, and a big part of the problem is this 3. It takes a lot of electricity to produce aluminum metal. Okay, what's this? 4 electrolytic cells contain cesium chloride, lead chloride, and gold chloride. If a current of 5 throws through each of these cells, which will deposit the greatest mass of metal in an hour? Okay. 3 separate questions again, but again they have a lot in common. IT equals FE. First thing to note, if they're all getting the same amount of current and they're all getting the same amount of time, they all have the same I and the same T, and everybody has the same F, they're all getting the same number of electrons. So let's find that number. That'll be IT over F. We're treating them all the same in this way, so they're all receiving the same number of electrons. It's just what will they do with them afterwards. Current is 5 amps times the time is 3,600 seconds. That's an hour. Divided by 96,500. Everybody is getting 0.1865 moles of electrons. But what will they do with them? Cesium, according to this, has a plus 1 charge. A single chlorine ion is minus 1, so the cesium must be a plus 1. So that means the cesium must only need a single electron to turn into cesium metal. 1-to-1 ratio means we're going to get 0.1865 moles of cesium. We'll get the masses in a second. For lead, the lead ion must be +2 because it's got 2 chlorines on it. So for that one, we're talking about lead 2 plus 2 electrons producing lead metal. 0.1865 times 2, or I'm sorry, divided by 2, right? It's 1 lead for every 2 electrons, so times 1/2. 0.1865 times 1/2, we're only going to get 0.09325 moles of lead. The step I should have shown is this times 1 lead for every 2 electrons. If I had done this, I never would have slipped. So, learn from me, don't shortcut. Be careful right there. So that's our moles of lead. And, last one, gold. The gold ions are +3, so we're taking Au3 plus 3 electrons and producing gold from them. We're making 1 gold for every 3 electrons, so 0.1865 divided by 3, or times 1/3, means we're going to get 0.0622 moles of gold. Well, moles are great, but they actually wanted masses, so we have one more step to do here. The mass of cesium is its number of moles times its molar mass. So 0.1865 times, I have no idea what cesium's molar mass is. It is 132.91. From that we get 24.79 grams of cesium. Next contestant is lead, 0.09325 moles of lead times lead's molar mass is like 207.2, I think. Yeah, 207.2 grams per mole. So its mass is 19.32 grams of lead. So far, cesium is winning, but gold is pretty heavy. Let's see if it can take over here. 0.0622 times molar mass of gold is 196.97. So its mass is 12.25 grams of Au. So no, the gold does not take over. The cesium is the one with the highest mass. Gold has a really high molar mass, and so does lead, but the fact that we were dividing this by 2 and this by 3 held them back. Cesium, you can produce a lot of cesium quickly because it only costs 1 electron to make a cesium atom, and that definitely matters. 2 more on this page. What have we got? 2 moles of electrons flow through an electrolytic cell. What mass of product is collected at the anode? Okay, so anode is a little unclear. If we have aluminum oxide, we have aluminum ions, and we have oxide ions. And if we're electrolyzing these, we're going to make aluminum metal and oxygen. This one would produce 4 electrons, and this one, I'm just balancing the half reaction. Sorry, I don't know where. I was looking at this 4 and still thinking about it. I should have written 3 there. 3 minus. Okay. Which of these happens at the anode? Aluminum here is going from +3 down to 0. That's a reduction. Reduction has a C in it. That happens at the cathode. So that is not the one we're talking about. Forget that. We're interested in this. 2 oxide ions can turn into an oxygen atom as long as we rip their electrons off. So the question is, how much oxygen can we make with 2 moles of electrons? our formula says if our number of moles of electrons is 2, you know what, we don't even need the formula. We have moles of electrons. That's exactly what we need here. From here, the moles of oxygen we can make would be 1 oxygen for every 4 electrons. 1 oxygen molecule for every 4 electrons. 2 times 1 divided by 4 gives us 0.5 moles of O2. And the mass of O2 is N times M. 0.5 moles times the molar mass of oxygen, elemental oxygen, is 32. From that we get 16 grams. That decimal should be there. Looks like I was working a little too fast. 16 grams of oxygen should be correct. The electrolysis of molten aluminum chloride. Okay, so here there are 2 possible reactions here, or 2 reactions that will happen here. Aluminum ions will get reduced to aluminum metal, and chloride ions will get converted to chlorine, and they'll release electrons while they're at it. They tell us the chlorine is happening at the anode, which seems reasonable, but the question is about the cathode, so let's focus on that. Actually, now that I look at the question, we are going to need this. If we made 20 grams of chlorine, they want to know how much aluminum are we going to get. Funny thing, we could do this with IT equals FNE, I suppose, but really this is stoichiometry from long before this unit. If we make the total cell reaction here, we need to match our electrons. We can put a 2 times that, 2 times that, 2 times that, 3 times the, 3 times the chlorine, 3 times the chlorine, and 3 times that. Cancel electrons. Here's our overall reaction. 2 aluminum ions and 6 chlorine ions convert to 2 aluminum metal and 3 chlorines. So you could give this to a friend in Chem 20 and they could handle it. If we had 20 grams of chlorine and they want the mass of aluminum, how do we do this? Get a number of moles. That's always rule number 1. 20 grams of chlorine divided by the molar mass of 70.90 gives us 0.2821 moles of chlorine. So how many moles of aluminum do we have? The ratio of these things is 2 to 3. Get 2 aluminums for every 3 chlorines that there were. 0.2821 times 2 divided by 3 gives us 0.1881 moles of aluminum. Multiply that by the molar mass of aluminum. Mass equals number of moles times molar mass, and we get 5.07 grams of aluminum metal produced. We could have done this by going from 20 grams to moles of electrons to IT equals some number and then use that same number on the aluminum and found 507, but this is more efficient and you already know how to do it, so I'd probably recommend this if you had a choice. We wouldn't go through the IT equals FNE ritual unless we really needed to. So I hope you like this. If you really want to see the other way, let your instructor know and they can take you through it perhaps.